In today's video, we're going to be talking about circuit diagrams. After watching this video, you should be able to draw an electric circuit basically using the appropriate symbols. So a battery will have a certain symbol, a switch will have a certain symbol, a light bulb will have a certain symbol, and you're supposed to be able to combine all those things together to be able to draw a diagram of various circuits. So let's get right to it. So the very first thing is that we're just going to talk about some of the symbols. An electric cell, which is just basically a fancy name for a battery, looks something like this. This would just be one cell, where basically the long line represents the positive end of the battery, and the short line represents the negative end of the battery. All right. If you have a series of batteries, so for instance, let's say you have 3 batteries, which is what's displayed here. Here the long lines still again represent the positives and the short lines represent the negatives, and here is 1 battery. Here is 2 batteries, and then here is the 3rd battery. So if you can kind of see that basically a long line and a short line is 1 battery. Well, when you start stacking them up on top of one another, you have multiple batteries lined up. The second symbol I'd like to talk about is something called a switch. Right? And a switch gives control over whether or not current is able to flow through a circuit. And you guys probably are very familiar with switches at your house. If you flip the light switch on, the lights turn on, and basically what you're doing is you're making this piece right here close, and that allows for current to flow through the circuit, and so you have your light turn on. And when you flip the light off, you basically put it in this position where current is not able to flow through, and so it breaks the circuit, if you will. Okay, so this is the symbol for a switch, is basically something like this. A resistor is any object placed in a circuit that lowers the current. And basically all objects within a circuit can be considered a resistor. So for instance, appliances, your refrigerator, your washing machine, your heater, your hair dryer, whatever you're putting in there is going to be considered a resistor. Lights are resistors, and even the wires themselves can be in a way considered a resistor. And again, remember, resistors are measured in ohms. Okay? And in all of our diagrams in this class, we are going to make the assumption that the wires have 0 resistance. Even though that's not exactly 100% true, we're going to just make that assumption that compared to the other objects that we place in our series, in our circuits, the wires themselves are going to actually provide very little resistance compared to, say, a lamp or something like that. A variable resistor really serves the same function as just a plain old resistor. You'll notice the only difference between this picture here and the picture in the previous slide is that I've added an arrow in. Okay, and that arrow is indicating that we can actually change the amount of resistance that this resistor applies. So a really good example of this would be like a dimmer switch. If any of you guys have dimmer switches at your house, as you slide the switch up, the lights get brighter, and basically what the resistor is doing is it's allowing more current to flow through the circuit so that you have brighter lights. As you slide the dimmer down, you basically increase the resistance at this variable resistor, and so the lights become dimmer. Right? And back in the day, stereos used to kind of do the same thing, where you would adjust the volume, and that was actually a variable resistor in the stereo systems. I don't believe any longer use that type of technology, but back in the day, that's how they did it. A voltmeter basically is a device that measures the potential difference or the voltage drop in a circuit from one side to another. And this is the symbol for a voltmeter. It's basically a circle with a V in it. It is connected in parallel. So what it would kind of look like is, let's say I have a resistor here, and I could then stick my voltmeter here to basically measure how much voltage drop this resistor provides in my circuit. Okay, and so you notice I've made this in parallel. Basically, the current has 2 options for how it can travel. It can go through the resistor or it can go through the voltmeter. Voltmeters typically have a high resistance, so that the majority of the current flows through the other branch of the circuit. Okay, so current isn't probably going to choose to go through the voltmeter. Instead, it's going to go through the resistor. And this again would be measured in volts, because that's what we measure potential difference in a circuit. It would be in volts. An ammeter is basically something that measures current, all right, the current passing through a circuit. And if you want, you can think about it as in like counting the charge going through the wires, okay? Or if we go back to my skier analogy, it'd be like the number of skiers passing a point in a circuit, okay? An ammeter must have a low resistance basically to allow the electrons to freely flow through the circuit. And it is connected in series. And if you remember, what does that mean? Well, let's say I have a circuit here and I have a resistor right here. I would put the ammeter right in line with this circuit. This is called in series. So the current must go through the ammeter and then it must go through the resistor. Okay, so that's called connected in series. It is measured in amps, okay, which makes sense. That's the unit for current. Okay, so you're going to get a value in amps from an ammeter. A light bulb and a fuse, I didn't have a real cool picture made on PowerPoint, so I'm just going to draw them for you. Let me get a cool color here. Let's go with blue. Blue sometimes doesn't show up real well. We'll go with white. So a light bulb, or a bulb in general, so I'll write bulb here, is just basically a wire on either side with a circle, and then you have like two squiggly things in it. Now, I'm not a real good artist, but that's supposed to be a light bulb or a bulb in a flashlight or whatever the case may be. So if I say, wire a light bulb into a circuit, that would be the symbol I'm looking for. Is basically a circle with like two little squiggles in it. If you have three squiggles, it's not the end of the world. I'll probably be able to figure out what it is you're showing me. A fuse would look something like this, where basically you have a wire, put a dot, and then you make this kind of cool curly Q looking thing, and this symbol right here would be a fuse. Okay, so these are light bulb, fuse. So if you're asked to draw that in a circuit, you have now the symbols for it, light bulb and a fuse. So let's do a few example problems. It says a single cell, which basically means one battery, a light bulb and a switch are placed together in a circuit such that the switch can be opened and closed to turn the light bulb on. Okay, so how would I draw that? Well, let's start with the battery, and I'm going to draw a big line and a little line, and then I'm going to start to draw a wire. And you can make it go in any shape you want. You can make this circular, triangular, whatever you want, but I typically go kind of in a box. So I drew the battery, there it is. I need to draw a light bulb, and if you remember, a light bulb is just a circle with two squiggly things in it. And then I'm going to keep on going, and it says they want a switch in here. All right, if you remember, a switch looks something like that. And then you better connect that circuit so that's all connected. Now, as soon as I close this switch, if I push this switch down, the light bulb should, in theory, turn on. Okay, that current should start traveling through the circuit, and the light bulb starts to glow. Very exciting. Okay, so this is what an example of what I could ask you to be to draw a schematic diagram of basically this text right here. All right, let's do another example just to keep kind of give you a good feel for what this is all about. A 3-pack of D cells is placed in a circuit to power a flashlight bulb. Okay, so basically what we're looking for here is that we have 3 batteries, and it looks like 1 bulb. Okay, so how would I draw that? Well, I'm going to draw my batteries, and so I have a big line and a little line. Now that's just 1 battery, so I have to draw that 2 more times. Big line, little line. That's 2 batteries, and then 1 more big line, 1 more little line. Now I have 3 batteries, and I can start to draw my circuit. I'm going to draw my light bulb right here, and swing her around and complete it. Okay, and this is what it would look like. If they would have said put 4 light bulbs in this, well, I just draw 4 more of these along this line, and that would be all good. Okay, or whatever it is they want. If they want a resistor in there, we could certainly throw a resistor. Just whatever they're asking for, you just basically put in that picture using the correct symbols. Okay, so that takes care of today's lesson. I will see you guys next time.